question 6. I think question 6 is on dynamic, although they give you okay. They are just testing you on your Newton's second law. So they give you the mass, they give you the speed, okay, but this speed is a constant speed, and constant speed basically translates to acceleration equals to 0. You are asked to find the resultant force, and you know that by Newton's second law, your resultant force is F net equals to m times A, and in this case, since A is 0, your resultant force is 0, so that's why you get A. Okay, then after that is about free fall. Okay, question 7, an astronaut conducted the experiment on moon, and since the moon doesn't have an atmosphere, there's no air resistance, so the object is going to fall basically under the influence of the moon's gravitational field, meaning that both the feather and the rock are experiencing the same gravitational acceleration. So as a result, they will reach the ground at the same time. Okay? Okay, for question 8. Question 8, right, it requires some form of intuition. So normally when you take a lift, right, you feel the jerk immediately when the lift is going up. If not, it will be when the lift is coming to a stop. Now the reason why is that our body actually cannot sense speed. We can only sense acceleration. Okay, the reason why is because that if you are traveling at constant speed, the acceleration is equals to 0, and so the net force will be 0. So your body can only senses actually forces, or you can simply say acceleration. So in this case, the reading on the weighing scale is 720 when the lift is moving upwards at a uniform speed. So when all the object inside the lift is moving at a constant speed, meaning that there will be no net force acting on whatsoever, the weighing scale will only experience your weight. Okay, so therefore this one is true. Okay, if you look at B, the reading of the weighing scale is 720 when the lift is stationary. So when the lift is stationary, basically it's like just you standing on the weighing machine. So of course it will register your weight. So this is true as well. Now we will skip and look at option D for the sake of going through. When the lift is accelerating upward, okay, meaning that when the lift is accelerating upward, meaning that the weighing machine is also accelerating upward. So if you take the perspective of this man, it is as if that the weighing machine is accelerating towards you, and as a result, there will be a force pressing against you from the weighing machine to you. Okay, so by Newton's third law, there will be an equal but opposing force from you onto the weighing machine, and therefore, okay, the weighing machine is going to weigh more than 720. So option D is actually false. Okay, so let's look at option C. Okay, when the lift is accelerating downwards, the weighing machine is 504. Okay, so in this case, when the weighing machine, when the lift is accelerating downwards, the weighing machine is also accelerating downwards. So it means that due to your inertial, you'll be like staying stationary when the weighing machine is going down. So as a result, okay, the forces acting on the weighing machine will be less because the weighing machine is trying to get away from you. So in a certain sense, you will be being lifted up, okay, in a certain sense. So as a result, you won't be getting 720 on your weighing machine, you're getting less than 720. So in fact, option C is true. So I think I have written here wrongly. The answer should be D. Okay, so what's wrong here is that when the lift is accelerating upwards, you should be getting something more than 720. So this thing should be more than 720. Okay, of course what I am trying to explain here is actually from a very intuitive approach. If you want to do it more systematically, you can actually draw a free body diagram with all the force factor acting on the weighing machine. Okay, why is it that you should draw on the weighing machine? Is because you're getting the reading from the weighing machine. So I would not want to go into that kind of detail here, but you can always come and look for me after your lessons, and I can show you how to do it. Yeah? Okay, question 9 is a little bit tricky. The reason why is because that they're trying to distract you with a larger cylinder. Okay, so what happens is that they tell you that when this ball is being lifted up, actually the cylinder goes down by 20 cm cube. So notice the cm cube here, they are actually already telling you that when the ball is lifted up, the cylinder is the cylinder, actually the reading is telling you there's a reduction in the volume of 20 cm cube. Unless the reading here is 20 cm, then you will be affected by the cylinder's cross-sectional area. But since they already give you the volume, you know that this 20 cm cube volume is actually the volume of the ball. So when this ball is placed into this cylinder, how much does the reading goes up? It will be 20 cm cube. Nothing actually changes, okay, because the ball's volume is fixed. So therefore you will get B. Okay, don't overthink. Okay, for question 10, okay, question 10, you need to know that friction, actually the amount of friction acting on an object depends, of course, on the surface condition, whether it's rough and all that. But the friction is also dependent on the weight of the bucket. Okay, because if you let me illustrate to you. If you have an object, if you press onto this object, you will realize that your friction will actually become larger. So actually the friction and the force pressing the object onto the surface has a direct relationship. So the friction is actually directly proportional to whatever force that is pressing the two surfaces together. So in this case, the force pressing the two surfaces together is actually the weight. Okay, meaning that we need to calculate the weight. Okay, so why? Because down here, yes, the mass has an obvious difference, but as you can see, the gravitational field here is different as well. So in order to work out, which bucket is experiencing a higher frictional force, you have to first find the weight. So to find the weight, you just take m times g. So in this case, will be 16 Newton. Down here will be 10 times 1.6, which will give you 1. So they are going to get the same weight. So since they are getting the same weight, the frictional force acting on the bucket when it is moving will be the same. So therefore, both are pushed with the same ease because the weight of each bucket is the same. Yeah? Okay, so this is the reason. Okay, question 11 is on moment. Since they didn't give you any value, we do not need to really calculate. So what they are asking here is that why is it that the arm is balanced in this position? So whenever you have an arm, you need to take note whether the arm actually has a mass or not. So let's read it carefully. Blah 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 blah. Did it talk about the... Okay, so it didn't talk about it. So anyway, let's read up on the option. Okay, the moment of C equals to the moment of P. Okay, this statement here is correct. The weight of C is equals to the weight of P. This is wrong. Why? Because this is the weight of C. This is the weight of P. Okay, and because the weight of C from the pivot is a smaller distance when compare it with the distance from the weight of P to the pivot. So this is big D. So you know that the moment of C must be equals to the moment of P for it to be balanced. So what here we are assuming is that the arm actually has no mass, okay, insignificant mass. So down here, you will have WP times D. Down here you have WC times small d. So since you know that this big D here is big and this is small, in order for it to be balanced, WP must be small and WC must be big. So therefore the weight of C cannot be equals to P. For completeness sake, we are going to look at C first. So the moment of C does not equal, nope. If the moment of C and moment of P is not equal, this system will not be balanced. Down here, the moment of P equals to the weight of C. Now, moment of P is measured in Newton meter. The weight of C is in Newton. So when you say equal, you know that it is wrong. It is like saying that apple is equals to orange. It doesn't work that way. Okay? So let's look at the last choice. The moment of C equals to the moment of P, which is correct. The moment of C the weight of C does not equal to the weight of P, which is correct. The weight of C will be larger than the weight of P. Okay, question 12. Question 12 is on free body diagram. So down here you need to think quick on the fit. The reason why is because that you need to sketch a free body diagram. So you know that this thing is in equilibrium. Equilibrium means that the force factors, okay, must be in a closed triangle. So let's draw it. So I know that it's going to be a closed triangle. Okay, so this is 30, right? Okay, let's draw it properly so that you don't get confused. Okay, you know that there's a force here which is 30. There is the force due to gravity, which is weight. There's a mass here, right? So this one translate to mg. Okay, and you know that there's tension. You know that it must be a closed triangle because it's an equilibrium. So it goes this way, it goes this way. So finally, it must go this way. Yeah, so it forms closed triangle. And you know that this tension is 50 Newton. Right? So this one is a right angle triangle, right? So what can you see? You want to find the weight, right? So isn't this a right angle triangle? Pythagoras theorem, you find that the W is actually equals to 40 Newton. So you are asked to find the mass. So since, okay, I will just do it. Okay, W is 40. So you want to find the M, you know gravity is 10. So therefore mass is 4. That's how I get B. Okay? Okay, question 13 is again on, is on energy already. Okay, so in this case, they give you a distractor here, 600 Newton. Why do I say that it is a distractor? Now, when you are finding power, power is equals to the rate of change of energy over time. Now, the energy here could take up many forms. It could be potential energy, it can be kinetic energy, it can be work done. Okay, now, but in this case, they didn't tell you any information on speed. So you know that KE can't do anything about it. About PE, since they are moving on the same level, there will be no change in PE. So that left you with work done. Okay, and you know that work done can be expressed as force times distance. Now the tricky thing is that this distance and this force factor must be along the same direction, meaning that the force is going to the right, the distance must be on the horizontal. Okay, it can be to the left, to the right, but it must be on the same line of action of the force. So in this case, you only know this left to right 3 meters. So which force do you pick? Of course, it's the force from left to right as well. So you would have your 300 multiplied by 3 divided by 20. That's how you get 18W. So I think that there's a mistake here. It shouldn't be 18,000. Okay, it should be 18. Okay, question 14. Question 14 is on the conservation of energy. So in this case, they tell you that this truck is moving from rest. Let me see. The speed of the object. Oh no. So the speed of an object at A is actually 4 meters per second, meaning that at A, if I look at the position at A, I would have some KE, which is equals to half mv squared, and because it is traveling, it is on a platformed surface, it will also have some PE as equals to mgh. So this will tell me what is my total energy from the very beginning. So this thing will travel all the way to B. So at B, of course, it will also have some KE because there's some speed, 1 meter per second. So there's some speed as well. Okay, and because of course there's a height, so your PE will be equals to mgh as well. They tell you about the length of track, and they tell you that actually there's friction. So meaning that the energy at B, is it equals to the total energy? No, right? Because this total energy, okay, some energy will go into the work done against the friction until it reaches B. So when ET goes all the way to B, actually there is already some energy loss in terms of work done. So let's put everything together. So your EA, energy at A, will be the mass times gravity times the height plus half m, oh, not enough space, m v square, which is 4. Okay, so the left hand side will be the total energy at A, and energy at B, which is here, will be the mass, gravity, the new height, plus half m v square plus whatever energy that is lost. So by solving this equation, you'll be able to find the E loss. So let's get this straightened out first before we move on. So of course there is a shorter way of doing this, but let's not do the shortcut way. If not, you do not know what is going on. So you will find that the energy loss is actually 7 joules. Now this energy loss, like I said earlier, it is actually due to the work done against the friction. So work done against friction, okay, is your F, which is friction against the distance that we travel, right? And the distance that we have traveled is 2.5 meter, which is given here. So we know that this is 2.5, this is 7. So you will be able to get the frictional force as 2.8 Newton. That's how you get it. Okay, the reason why is because that at any point, if you draw here, there will be a frictional force acting here. So this frictional force and this path, the 2.4, although it's curved, but the frictional force is going to follow the same path as this distance, right? So therefore you can still use W times D, okay, to find the frictional force. Okay, question 14 is on pressure. Initially I wanted to use a very mathematical approach, but then I realized that you don't really need to. Okay, you know that initially when you plug into the gas tank, you have this difference of 10 cm mercury. Now, when the gas pressure in the tank is further increased by 8, you would know that this thing here would become 18. So the new thing would look something like this if I want to draw it out. Right? This thing here and this thing here. This thing here would become 18 when this thing happens. Right? Yes, it is going into 18, but the way that the option is being phrased, they are talking about the left arm and the right arm. So actually, whatever goes down will be whatever goes up. So how do you accommodate this 8 cm difference here? Well, the left arm go up by 4 cm, the right arm go down by 4 cm. So total the difference will be 8 cm and you will get 18. So therefore, the option C is correct. The right arm drop by 4, left arm go up by 4. So in total, they increase the difference in height by 8. So that 8 cm difference comes from here. Yeah, because the pressure is increased by 8 cm. Simple as that. Okay, don't really need to go into mathematics.